joining this session, right? I hope this session will be useful for you, right? Do keep your microphone on mute, right? I think let's have the. If you have any questions, you can post it on the Q&A section, right? Uh, in my tab, I saw the Q&A, right? Let me post it again. So we have that Q&A. I will check that at the end, right? So I'll post it in the chat, the Q&A. Okay. Probably I'm not going to monitor the chat until I finish presenting, right? Okay, let's get started. You can see my screen, yes? I can see my screen from my phone. Give me a second. Oops. All right. So this is the agenda, right? I think I've posted this in the invitation, so I'm not going to read this. Yeah, we'll go through this, right? All right. So this is just introductions. Let me turn on my camera for a while, right? Hi. So this is me. Last year, cycling, right? I love cycling, but I've not been cycling for maybe 6 months now, due to various reasons. But this is in kind of my background. So I started in EPC company, McDermott. I did the engineering for upstream about 10 years. I moved to Wally Advisions, do a more of a front end feed feasibility studies type of work, right? Then I spent 1 year plus with operating company, a terminal operating. So FOPAC operates various types of uh, terminal, from oil tank, chemical tanks, right? And also they were also exploring LNG regasification terminal, right? So now since mid of 2019, I joined Asmentech as a solution consulting, right? Solution consultant. I focus mainly in Southeast Asia. I based out of Singapore. I have been supporting customer from Malaysia, Singapore, Indonesia, Philippines, Thailand, and Vietnam. So yeah, right. So maybe in the future, I will have a chance to meet some of you face to face, right? If I'm visiting my customer, and if you happens to be one of my customer, right? So that's me. I want to take too much of this time again. Let me move next. All right, just a disclaimer, right? I'm not a heat exchanger design expert, right? This session is not about designing the technical details of designing heat exchangers, right? But this is meant for showing you the workflow, right? In terms of how you can do the sizing within process simulation, HYSYS and Aspen Plus. Then you can also simulate using rigorously using the geometry, right? I think there are a lot of handbooks and articles related to heat exchanger design, especially shell and tube, right? So this is just some of it, right? There's one short article in Chemical Engineering Progress long time back. I think February 98, right? I think it's quite a good article about shell and tube heat exchangers, right? And in general, this workflow can be applied to any other heat exchangers within HYSYS or Aspen Plus and EDR, right? Okay, I think that's that. All right, just a little bit of housekeeping, right? Uh, Help keep your microphone on mute during the presentations. If you do have questions, there's a Q&A sections, right? I think initially when I prepared this is a chat window, but you can go to the Q&A section, right? I'll go through that at the end of the presentations, right? And at the end of the presentations, there's a feedback form also useful for me to get some feedback, understanding how I did, right? And also there will be also we'll send the recording and the slide deck from the via the feedback form, right? Okay. All right. So the first one, right? The first one is basically the first workshop I'm not going to go through. So, but the slide deck, what I've done here, the slide deck, I've prepared screenshots and detailed steps of the different workshop we're going to or different demonstration we're going to do, right? We'll share this later, right? So, okay, the first one is basically um, building this model, right? So building this model, which is a simple. I'm just going to talk through this one, right? So what I've done is very simple, just to demonstrate. This is I'm using Peng Robinson. I'm only using two components, which is methane and water, right? And basically, I'm just simulating hot gas, which is the methane, initially at 100. Then I'm reducing it to 50 degree Celsius using the water from 30 to 40, right? So if you define like this, of course, this one we typically the only parameters we define is the pressure drop for the heat exchangers, right? I'm using a simple endpoint, and I've defined the flow rate, pressure, the inlet conditions of the gas, right, including the compositions. Then I define the my outlet temperature target, right? So that's define the duty, right? Then I also define uh, my conditions. So this one is my conditions of my cooling water, the pressure and the temperature, right? Then I define the temperatures outlet I want, right? Then it will calculate the flow rate required, right, based on the duty from the gas side, right? So that's that, right? I'm going to copy this to another one, right? Right. So what I will do, right? Actually, I'm going to just I can put an adjust. Oh, let me open my other this one. Let me open this one. Okay, I want to explain why I did this. Right. Let me open this file. All right. So this one is exactly the same heat exchanger. Just now I copy, right? But the only difference is because this one is the flow rate is calculated, right? The flow rate is calculated because we define the inlet temperature of the cooling water and the outlet temperature of the cooling water. What I did is actually I removed the specifications of the temperature outlet, but then I copy using this balance of the flow rate, right? So I'm defining the flow rate here. This flow rate is actually copied using this balance, right? The reason is when we use the rigorous heat exchangers, right? This input needs to be defined, needs to be known, right? It cannot do this back kind of the back calculations uh, yeah, for the rigorous heat exchangers. That's the main reason, right? Okay. Um, right. I hope it's clear, right? Okay. So next, let me go back. So that's basically the simple heat exchanger. This is the step, right? We're not going to go through, and I explain about copying this, right? creating balance to just copy the mass flow, or you can just copy the mass flow directly, right? So now we want to do heat exchanger sizing, right? So okay, so when we typically a process engineer creates a process simulation, of course the process simulations will contain probably upstream equipment of the heat exchanger and downstream equipment of the heat exchangers, right? And when we do the process simulation, maybe during design, right, we want to know the heat and material balance, the duty of the equipment, the flow, the properties of the streams, right, for us to actually size the equipment, right? So now, right, we want to size the heat exchangers, right? And in HYSYS, you can also use Aspen EDR within HYSYS to do the sizing, right? So this we have the informations of the process conditions, the flow rate, and the duty, right? The temperature requirement. So we are going to do the sizing, right? So what you can do is you double click the heat exchanger, right? So when you open, right, you can go to part. Sorry. Okay, so this one is I have. Let me do one thing. This one is already converted. Let me convert back to simple first. All right. So this one is a simple heat exchangers, right? Currently, I'm going to do this size heat exchanger. So when just now when I open, right, it doesn't show this size heat exchanger because it's already, this is a completed workshop 2 solution file, right? That's why it's already completed the sizing, right? Let me save this just to show I don't overwrite. Okay, so I will click this size heat exchanger, right? So typically you can choose different options here. So auto size, it will do based on its assumption and size, right? Using template, you can save template in EDR, and it will use the basic assumptions, right, in that template, right? Or you can also size interactively. Typically, I choose this size interactively. So when you choose this, it will bring up the EDR form at the back. It will bring up the EDR form. So you choose and click convert, right? Okay. So what you can see here, there are several tabs here. The first tab is the geometry, right? The geometry, you can see now in the calculation mode of this is the EDR windows, right? You will, when you open EDR standalone, you will see similar windows like this, right? So here is a geometry, right? So the geometry, there are two section here, right? So the first section is configuration. So the configuration is the basic specification. The things we need to specify, right, is, for example, thema type. So this thema type we need to specify based on the service of the both the hot and the cold liquid, right? Perhaps if there is the temperature difference, so you might use different thema type, right? Then the other thing is also tube size is needs to be defined, right? So this configuration, this one is not something optimized, right? It's not something EDR will change and optimize, right? So we need to define this the tube pattern, whether it's triangular, square, right? Buffle type. So these are the basic configurations, right? So what are, oh, when we're doing these calculations of design and sizing, right? What are the things actually EDR is sizing or optimizing, right? So mainly is it will calculate, of course, the number of tubes, right? number of tubes. Then it will also optimize the tube length, right? It will iterate. So what it will do, it will do a different combinations of these parameters, different length of tube length, right? Then it will calculate the number of tubes. Then it will also define the size of the shell, right? And with all the baffles arrangements, baffles spacing, and whether more than one heat exchangers is required. So these are the things which EDR will optimize or will iterate and give you the optimum, right? And when we do this right in HYSYS, that's not. I mean, we cannot define in terms of the constraint of the optimizations, and we will go through that later, right? So this is like a quick size, right? So this is the geometry page, right? Then next is we go to the process, right? So the input is geometry and process. You can see, right, because we are running this within HYSYS, right? So all the stream data is already transferred, right? There are things you can further define, right? For example, if you want to add flow rate multiplier as margin, you can define that, right? If you want to add duty multiplier as also as margin, right? You can define that. And for example, this is the criteria, right? Allowable pressure drop. You can define this, right? So I'm leaving that, right? Then also maybe I'll put 70. Okay. Then also fouling resistance, right? So this is, you can refer in to some you can refer to guidelines, what type of fluid and what in terms of fouling resistance you need to apply, right? So this is also kind of a margin, right? Margin for operational. Okay. So the other two tab is a report, kind of after results, right? So this is are the two input, right? So it does make it easier for us to actually not having to input all this, right? Not having to define the compositions, the inputting all the process parameter in a standalone EDR or any other heat exchanger tools, right? So it's already copied, the properties is already there, right? So now we can click size, right? So we can see it will do some iteration. You can see is doing some iterations. There are 17 cases is considered, right? And we can take a look here. The the heat exchanger result, right? So you can see this is the roughly the sketch of the heat exchangers is one pass for the one pass for the cold, right? And this is two pass for the hot stream, right? So you can also, this is setting plan and this is the tube layout, right? So what I will do, right? Uh, I will save this. I will save the EDR file, right? So I will save the EDR file, right? So I will put this, maybe I put it a new folder, right? So I'll put this heat exchanger design. So this is a design case of the EDR, right? Okay, let's say, so let me go to that folder, right? So I can open this EDR, right? Okay, okay, so I think we've done workshop 2. So this is the what I've explained. I'm just flipping this through, right? Right, so we've done this. Okay, so what I will do, right? Now I'm going to also accept. If I click I've clicked size to size. I click save to save the file, the EDR design file. When I click this accept design, right, it will transfer the geometry back to HYSYS. So if I click this accept design, right, it will convert my simple heat exchangers to a rigorous shell and tube heat exchangers, right? So you can see here, this my heat exchanger here has become uh, rigorous heat exchanger, right? So how do I know? I double click here, I click here, is active, right? Compared to if I click here, is empty, right? So this is still a simple. And you can also refer to this dashboard. There's a dashboard of exchanger here. You can click, right? So you can see here, this is my E100, my original model, which is I maintain still simple, right? So this is the rigorous, right? And it gives you summary of in terms of the different parameters, the key parameters, whether there's any potential issue or not. So all currently is great, right? And you can also show legend here, like whether the model status, right? So it's sometimes it's not showing. Okay, so the model status, this circle is actually here. Uh, so it's showing what is does this mean? You can click show legend, right? Oops, it's not appearing. Or does it appear somewhere else? Okay, so it is basically showing, okay, this is a simple heat exchangers, right? This is rigorous heat exchangers, right? So that's the dashboard, right? So now, yeah, so this that when I click that, the legend should appear like this actually. Okay, so what I will do now, I will open our EDR design file, right? So the design file is this. I'm yeah, right. So I'm going to open this, right? So the in EDR, right, you have more flexibility, right? Of course, there are advantage of running EDR within HYSYS. To me, is the biggest advantage. I don't need to key in all this data of properties, data, etc. Right? Uh, now, but here you can also do a little bit more, right? So you can define, for example, you can define geometry limits. If you have a space constraint, you can define, right? Uh, any the optimizations, you can choose the basis for optimization, either minimum cost or minimum area, right? So minimum area doesn't mean that always a minimum cost, right? So there are two things you can optimize for, right? So these are handles, right, which you can use in the standalone. And typically, I think people will use this, will generate that file, open it in EDR, and fine tune it, right? So one of the fine tuning is like, for example, it shows you the optimization part, means the different configuration EDR has considered, right? It will also report against the key criteria, pressure drop, um, whether it's meeting the duty or not, right? The duty typically it will be reported by area ratio, right? Uh, okay, so this whether there's a design issue, right? For example, let's say you can see here the tube length is 2 meter 85, right? So let's say I'm going to choose a shorter one. I can also go back and choose a shorter one. For example, uh, I want to choose this one, 1.5 or 2.25, right? Let's say I choose this one. I can select, means that I'm selecting this instead of the recommended that, right? It could be because of constraint, etc., right? Okay. So if I run this again, let me go to the Okay, so you can see here the size is 2.25, right? So we can evaluate more, right? And the other thing also, we can switch sometimes. If you see here, right, in the design we have design and rating. I think we are going to talk about mainly design and rating first, right? Here, if you go to exchanger geometry, right, same thing. uh, Geometry summary, right? These are the inputted, but this has not been inputted, right? Because these are the output or the result of the design. Okay. So next is basically, if we want to fine tune it, people do switch to rating mode so they can change certain parameters, right? So I've talked about this steps. Now we're going to switch to rating mode, right? So what happened when I switch to rating mode, right? The results of the design geometry will be copied as an input, right? So I will use my current because I want to use this case, right? So it will copy all my geometry as an input, right? Of course, I can run this, right? Then what I will do now is I'm going to save this case, right? So I'm going to save this case as H rating 2, right? Because I've changed the, the geometry, right? So I'm going back to my uh, flow sheet, right? So if I go back to here, right? Okay, so this geometry, right, is the first geometry when I click the accept change, right? But now I have changed my geometry, right? This is initially 2.2, 2.85 meter length, right? But now I've done my more detailed design. I've selected and I've saved my geometry in the rating file, right? I can import that rating file again also to this to replace, right? To replace this geometry, right? So I can click this import. This is my rating file, right? Just now I can open it, right? So now it is overriding, right? So it's changing with that new design with the shorter tube length, right? Okay. So now it's done, right? So it's updated, right? So next, so this is the step to import back, right? Okay. So next is I want to also mention, just now I have shown, but I wasn't explaining, right? So sometimes, right, we don't want, and this is very simple model, just one heat exchanger. But sometimes you have uh, a series of equipment. The advantage of doing this is also you can see the impact of change, the input change into the heat exchanger to the downstream equipment, right? If you build that downstream flow sheet, right? The interactivity, right? So, but sometimes also the model is large, right? We do want to calculate rigorously at a section, at some sections, right? But to come up with maybe optimization solutions or to get the whole flow sheet converged, right? Sometimes we want to do some approximation, right? And one of the approximation is using the UA calculated by the EDR, right? So I can convert that back, this rigorous heat exchangers. So this is the rigorous heat exchanger. I can go to this exchanger, right? So this is, you can see, referred to simple, means this is currently in rigorous, right? So I can click this refer to simple, and I can choose. I want to use the UA calculated as a specification, right? So now it becomes the UA of the A is constant, right? The U is depending, could be based on the process conditions, the flow rates, etc. will affects the U, right? So when we do this approximation, of course, we are assuming that the U is constant, right? Maybe we are assuming our process condition doesn't change too much, right? Okay, so this is sometimes we need to do this, right? We want to solve our complex flow sheet faster, etc. We revert back to simple mode, right? Okay, so that's that, right? So I think the next one, uh, okay, let me, before I go to the generate data sheet, right? So let me go to the Q&A first, see if there is any question first. Okay, so the first question, how realistic is the price of the heat exchangers in the EDR? Is it based on recent market price? So typically, all the cost data in Aspen Tech, right, be it EDR for the heat exchanger or the Aspen Capital Cost Estimator, typically is database of 1 year lag, right? For example, if it's we are in 2024, we recently issued 14.2. That cost database is based on 2023, right? So, but having said that, right, we typically also need to look at past data of maybe your supplier and vendor quotations, right? And you need to calibrate what we do typically in especially in capital cost estimator, right? We calibrate the costs, right, to match with our historical data, right? But the other thing also, the heat exchanger, right, is like the equipment cost, right? And you might be the vendor cost is actually including maybe shipping costs, etc., right? So that needs to be a factor also, right? In ACCE, it will also estimate the bulk material cost, right? That's something you get out of Aspen Capital Cost Estimator, right? So I hope that answered the question, right?
Thanks.
From
Yeah.
Yep. Okay. If no other questions, let me go through the last part is generating the data sheets, right? Okay, so now we have, I'm going to refer this back again to Rigorous, right? Sorry. So I will import the EDR back. Okay. So if you have Aspen Basic Engineering installed, right, you will have this datasheet icon, right? So I'm going to select workspace, right? And this can be set up in kind of enterprise setup, means client and server, right? The data is stored in server, right? So in that case, you click this join project team and you point to the server. You give the server location, right? So in this case, I'm just working out of my laptop. So I'm using my personal workspace, right? So what it will do, this, right, is actually going to read the flow sheet. It will read the streams and the equipment model available in the HYSYS file, right? Then it will map to equipment type, right? So first, I'm going to create this as a new, right? So this is maybe I said activated heat exchanger 2, right? So it's creating the data structure, right? The database, right?
It is available in which tab?
The tab is on the home tab. Home tab, then this there's a data sheet at the end, right at the end. So, but this is only appear if you have Aspen Basic Engineering installed. Right?
Okay, if I have server license, I can do with server license. Okay,
Correct. Yes.
I can give the IP. Oh, it will automatically come, right? Right.
Yeah. Okay. So what I will do now, right? So because I create duplicate, right? I don't want all this, right? So I only want the heat exchanger 2 and whatever stream associated with the heat exchanger 2, right? So I go down. This is the right. Okay, so you can see here it's actually mapping. Like this one, it maps. It knows it's a heat exchanger. It maps to shell and tube, right? But it can also map to a different type of heat exchanger. Like for example, two-stream heat exchanger can be also like a plate exchanger, right? So currently I leave it like this. I can transfer the data from the simulations to this database, right? So you can see currently we don't have the object name. I click transfer. It will create the object name, right? It create an object in the database, right? Then I can go back to this click explorer, right? So you can see now it's creating this object already. I can go to explorer, right? So now explorer is I'm exploring the object in the database, right? Here, right, there are many options for creating datasheet, approving datasheet, issuing PDF, right? Let it generate first. So you can see this is the workspace ACTHE2. All right. So let's say I want to issue a data. I want to create a data sheet for this. We do have some templates, right? So I select the equipment first, then I click this add new data sheet, right? Then I can choose the different types, and one of that is Aspen Tech format for shell and tube, right? And I click OK. So it will open up this data sheet. Right, you can see the process data is filled. Some construction data is already filled, right? And you can open this also in Excel, right? But I'm going to show another way of doing this, right? Generating the data sheet. You can export this to Excel as a dump Excel or as a link Excel also, right? Then I want to go to Aspen Basic Engineering Explorer, right? So I'm going to connect to the same database, right? So I'm going to connect to the database, the ACT, right? This activated exchanger 2. I can open that. Here, if I go to the datasheet, right? I know I have this datasheet, right? I already create one datasheet. So this is right. So if I double click, it's opening this Excel link datasheet, right? This is Excel link. Whatever I type here, like for example, client myself, right? It will be reflected in the this one, right? You go right, it will be reflected in here, right? So what I want to do, right? I can also import my EDR file, right? So here there's tools, thermal design. I can click this, right? And I can click file, import from file, right? So I can choose my rating, right? You have to choose rating file. I think if design file, right, like we know it doesn't contain the geometry, right? Rating contains the geometry, right? So I click that. So it's importing the data, right? It's opening the EDR from the background, reading the data, and importing, right? So thermal design result transfer. Okay, click OK. No need to see the log file at the moment, right? Okay. So actually, you can see, right? Yeah, that way gives you more data. Everything, all the geometry is filled here, right? So this is how you can generate the data sheet. Of course, all this, some data sheet you need to customize. That is kind of a topic for another session. Aspen Basic Engineering, how to customize it. But this is the capability available for you to transfer and generate the data sheet, right?
So
Okay.
one thing, you the Aspen work ASW is required, right? For this
Sorry, come again.
ASW Aspen worksheet is required, no? From Excel, converting into
Oh no,
Excel.
this is different. It's not Aspen Simulation Workbook. It's called Aspen Basic Engineering.
So this means Aspen Basic Explorer. With the
Aspen.
Aspen Basic Explorer, we can directly go to Excel, right?
Yeah, you can link with between simulations and Excel
But
using
but it is open with this that tab. Add in Aspen simulation work. Because
yeah. But I'm
we
not using.
didn't have that added that you can
I'm not
using
using
the
it. I'm using Aspen Datasheet, which is Aspen Basic Engineering. So this one is like a capability. The tab is available because it's installed, right? But this is the for linking between simulation and Excel. But I'm not linking between simulation and Excel. I'm generating datasheet from the database, which I import from the simulation, right? Okay, just to clarify the difference, right? So I'm using the Aspen Basic Engineering, right? Is the datasheet interface is Excel, but it's different compared to Aspen Simulation. Okay, let me check the chat. The chat is no questions, right? So I think we are a bit close, right? Maybe around 10 minutes, right? So we've gone through this, right? This is the steps, okay, to generate from within HYSYS as well as using the Aspen Simulation Workbook. Sorry, Aspen Basic Engineering Explorer, right?
Hey Fauzi, sorry to interrupt. I dropped a few questions in the chat in the Q&A space.
Okay. All right, let me check. What's the typical workflow to optimize flow sheet multiple heat exchanger? How do I start using EDR within HYSYS? Do I port over EDR to application? Okay, I think if I depends on where you are in kind of the engineering stage, right? Whether you are designing a new facility, whether you are trying to optimize existing, right? So, and to me, the first thing is to come up with the heat and material balance, right? But if you're modeling existing, that means typically I will do a simple heat exchanger, but I will use the UA approach, right? I will get the data of the UA from maybe calculated using EDR and input it right in the simple heat exchanger model, right? That way I can converge kind of a complex flow sheet much better, right? Only when I want to know more details like certain fouling conditions, then I can go to rigorous, right? So that's my first answer on the first questions, right? Okay, then how does rigorous? Okay, rigorous definitely will take more time, right? Because it will perform the uh, compared to the UA approach, right? The heat, the duty calculations is performed rigorously based on the geometry. The pressure drop is also calculated based on the geometry. It's not specified pressure drop, right? It will take more time, right? But that's why sometimes we do want to refer back to a simple using certain approach, right? Like UA approach.
Thanks, Fauzi. I think that answers the question. I just wanted to understand when you would apply UA and when you would go into the detailed EDR. Thanks.
Yeah. All right. Okay. Okay. So I think that's about it. The topics I want to cover. Right. Let me bring this up. Okay. So I hope that's useful for you, right? You can connect with me on LinkedIn. You can scan this QR code, right? I will share this what uh, this slide deck later on. Let me paste it here, right? Okay, then help me with the feedback form. This is the QR code for the feedback form, right? Uh, and the link, let me post it here. Right? Do help me with this. Okay, and so I'm planning for next session. I'm planning for currently. I'm planning thinking of my evening time. One in my evening, one in my morning time. Right. On this is mainly about how you size relief, estimate relief load estimation, size the PSV, and again generate the data sheets of the PSV within HYSYS or Aspen Plus, right? So if you are interested, you can register, right? I will post it in LinkedIn, but I will also post this in the chat. Second. Okay. I think that's about it. Yes. Right. So fill up the feedback form. I will send the recording and the slide deck to the email from the feedback form. Yeah. Okay. Any last question or any comments before we end this? All right. Hopefully it's useful. And also in feedback form, I also ask if any other topics you are interested. I will do my best to accommodate. Okay. All right. I think that's about it. Thanks a lot for joining. I hope it's useful. Almost 1 hour, right? Right. I'll give the 8 minutes back to you. Right. Thank you so much.
Thank you.
Bye.